coming. I'm Joe Cassady, Executive Vice President of Explore Mars and Director of Civil Space for L3 Harris Technologies. It's my great pleasure this morning to introduce our next speaker, who's with us virtually because of the events going on in Florida. But I'd like to introduce Jim Free. Jim is a distinguished NASA veteran with 26 years of dedicated service across multiple spacecraft and technology programs, starting his career as a propulsion engineer, yay propulsion, on the Tracking and Data Relay Satellite at Goddard Space Flight Center. He's held many positions throughout his career at NASA, including Center Director of the NASA Glenn Research Center, serving as Associate Administrator for Exploration Systems Development Mission Directorate, and now in his current position as Associate Administrator, the agency's highest-ranking civil servant. He's been recognized with numerous awards, including the Presidential Rank Award, NASA Distinguished Service Medal, NASA Outstanding Leadership Medal, the NASA Exceptional Service Medal, and the NASA Significant Achievement Medal, among many others. He's a graduate of Miami of Ohio with a BS in Aeronautics and a Master's in Space Systems Engineering from Delft University. Jim's career truly epitomizes excellence in project management, systems engineering, and leadership. So welcome, Jim.
Thanks, Joe. Thank you very much.
Great to talk with you this morning. I'm just going to kick it off here. So what are some of the things that are already underway at NASA today that are preparing us for humans to go to Mars?
Yeah, thanks, Joe, and my thanks to Patrick for a great presentation, as always. I always stress that we're working on Mars today for humans, and so I appreciate the question. This Friday, we're starting another HERA mission, the Human Exploration Research Analog, down at JSC. 4 people going in 45 days to a simulated Mars habitat. They're going to live and work in there till late June. We have the Crew Health and Performance Analog mission that's past 300 days down at JSC, where we built the Mars habitat. And I've had 4 people living in that. That goes until early July. All they need for the mission they went in with, from food and then the opportunity to grow food. I heard that question earlier. Of course, we're using ISS for learning as well, from learning of humans with their ocular health or immune system, supporting our Mars goals, the capabilities and technologies we test up there with carbon dioxide removal, the veggie system, which has been used numerous times on ISS, to the question earlier about growing our plants on the way. So for me, it's not just analysis going on right now. We're putting humans in to systems both here on Earth and in space.
Oh, thanks, Jim. That's great. We heard a lot just previously from Patrick about the architecture work. Is there anything else that you'd like to say about that activity and how you see it helping us to shape our path to Mars?
Yeah, the first thing I'll point out about it, Joe, is a quality in it that I've never seen in the agency until we started that, and it's really a whole of agency approach. For the architecture concept reviews, it's very important. We have the leadership of the entire agency sitting in that room, listening to the great analysis that Patrick and his team and Najud and their team have done to understand the architecture, but we're also making those decisions as an agency. We're identifying those gaps. We're identifying how to connect decadals in the Science Mission Directorate into the architecture process to knit those goals and objectives together. We lead, of course, with science. So what was exciting in the last one was some of what Patrick talked about, our focus on Mars. This isn't just about that near-term focus on what are we doing in these Artemis missions, 4, 5, and 6. We're talking about what do we need to do with those 7 decisions for Mars, the first of which is anchoring the science. Where do we need to go to achieve the goals that we need for science? And, I think Patrick talked about some of the white papers. That's another unique tool that we're using to describe our decisions one of the criticisms we've had before is we don't describe our decisions well enough. And some of those white papers are dual purpose. They're for the moon and for Mars. Things like what are the extravehicular activity drivers for the moon and Mars? What do we need for comms as well? All of this has really helped us start to align ourselves. STM, Space Technology Mission Directorate, Exploration Systems Development, aligning for the technologies that we have to get to a TRL level before exploration can pick them up and build them for flight. So we're kind of putting the whys with our architecture, the objectives, and knitting it all together into an architecture that comes together. And for me, I've not seen that in my time at the agency, and even when I was outside the agency. So I try and keep it in perspective that we could be very biased and say we've got this great plan in place, but honestly, I think a lot of the feedback we've gotten to date has said we have a good plan and are executing it.
Oh, thanks. That's actually a really excellent description. So that's a good segue, though, into the next question, which is, how exactly does Artemis help us prepare for human missions to Mars?
Yeah, so I talked about the whys and the objectives. So first, aligning ourselves from a strategic perspective with our whys of science and national posture and inspiration to the objectives, which the white paper I talked about some have lunar and Mars built in, some are Mars dedicated. Those objectives are similar. Things we need to do for lunar common nav, which are really driving the architecture. If you talk to Amit Kshatriya today, lunar common nav are 4-letter words to him because it's driving so much of what we're doing. And we're going to learn about that lunar common nav architecture. What do we really need to perform these missions? And a lot of that is people coming in with requirements. I need this 1/10 of a meter accuracy. Well, what's it take to do that? That's a 480 satellite constellation around the moon. Okay, well, we're not going to get a 1/10 of a meter. So it's the back and forth of requirements development to the actual implementation of these systems that we're learning. And we're also have this timing thing of everything we're trying to do at the moon is helping us learn on Mars. To go to Mars, it's an iteration because we're not going to have all our lunar missions done before we go to Mars. So how do we get the early buy down of the risks that we need for the early Mars missions, get that buy down on the moon, and then they kind of feed off each other. But we're going to have to set that in place as best we can because we're going to develop the systems for Mars. Because of the time it takes so long, we're going to have to set those requirements early. And then the last thing I'll say is, we're used a near rectilinear halo orbit around the moon, and the incredible folks that came up with it saw the potential for that orbit. I've also found a similar orbit out at Mars that we'll be able to use if that's the way we choose to go. But it keeps that commonality of operational concept between the moon and Mars as well.
Wow, that's exciting. Yeah, I hadn't heard that about the similar type of orbit at Mars. So we're at the Humans to Mars Summit, Jim. How important is the human part of Mars exploration? How would you answer people who say we can just keep exploring Mars with robots?
Yeah, I mean, the robotic exploration has first been just astounding to watch happen and evolve. When you think about even going back to the early Viking mission to where we are with Perseverance today, we've learned so much about various parts of Mars with the robots being there ahead of us. It's absolutely critical that the data that they bring back are things we're going to use to help inform. A simple thing like planetary protection, what we're learning of what we have to do to bring the samples back from Mars for the backward planetary protection. Eventually we're going to send these dirty, greasy things called humans out to Mars, and we have to be able to bring them back.
Yep.
And we need those requirements are essential for us to design around. And so that robotic exploration as one small piece, but with huge impacts, is important to us as well. What humans add to the equation is their ability to accomplish much in a fraction of time. I'll never say it well as Dr. Zerbukin said one time, but you know the human can say, I'm gonna look at this rock. No, I'm gonna look at this rock. I'm gonna look at this rock. So the distilling time of that information is quicker with humans, but we will learn where we need to go by some of the exploration that's already been done robotically. So to me, it's completely synergistic.
Yeah, that's great. Well, what then excites you the most about the science that we're doing now and the science that we're about to do in the 2030s as we move forward to send humans to Mars? And I guess a follow-up, I'll throw them both at you at once. What do you see as the big question or questions that we're trying to answer as we explore Mars?
First I'll say we're leading with science, which I think is very exciting to me. That interrelationship of the human exploration and the science is something again that I think we're maybe not. I'll say doing uniquely in that we're talking about the two together. We're not talking about human exploration and then doing science. We're talking about both of them together. What excites me most about the science, I'll say first at the moon, is just learning about fundamental planetary science questions, which obviously we're going to learn at Mars also, but we're right on the cusp of learning that at the moon, and our crews learning on how to perform that science, be it understanding the geology or taking special equipment with them, or when we can bring large amounts of regolith back with us. I think what excites me about Mars is that ability to do that quick science that we're going to be able to also bring that back and complement what we're going to get back from Mars sample return. And that we've laid out those science objectives that I talked about earlier. There's no doubt that we have set the objectives out there. We've gotten the input, hopefully from many in the room there with our workshops that were conducted for the objectives, that have been conducted for the architecture. We're trying to learn and evolve those. We've involved the international community in that as well. So the comprehensive nature of the science objectives that we have, I think all I want to see is us start ticking off some of those objectives by flying, and we have to overcome that. As to the big questions, it's how do we use that human machine teaming to answer those big questions. I'm not smart enough. I am and will always be a propulsion engineer first, but that teaming of the human and the machine to really answer the questions quickly, and developing an architecture that allows us to bring back as many samples as we can.
Thanks. Thank you. So what would you like our audience to take away about NASA's plans for Moon to Mars?
I think we lose sight of the fact that these missions are upon us now. We are going. We've launched Artemis 1. We're on a path to Artemis 2. We have the plan all the way through 6 for those missions in detail. We have hardware flowing for that today. We're on a path now for this larger architecture to really answer those 7 questions around Mars. We've laid out a technology plan that Spuds Vogel's refining now with some of our gaps. We understand the systems we're going to need to do these Mars missions. We understand what STMD space technology has to do. We understand the needs from our science community. Exploration is lined up to get there. We're making decisions and investments today. I talked about balancing what we need to get done on the lunar surface. We're thinking about that before we go on to Mars. The 2 things I'll say is we need to find the urgency in our stakeholder community, and obviously folks there are part of the stakeholders, but our community that funds us, to get this work done. That's our choice to do that. We have to convince people we have the plan. I believe we do have the plan. We're going to need budget to do it. There's no doubt about it. But we have to be committed to following through. And if I can do anything in my time at the agency now, it's to get on that path to follow through.
Wow, thanks. That's a really good inspirational message for us all, I think, Jim. So last question for you from my perspective, and I know you do have a hard stop coming up here. So as you've shifted into this new role, as you moved from being the AA for exploration into the associate administrator role, what's it been, about 4 months, I guess? Are there any new perspectives that position has given you?
I felt like the countdown last night was 4 months long. I felt like it's been a great honor to certainly have the roles that I've had at the agency and just work with the incredible breadth of people that we have at the agency and breadth of missions. As a center director, I thought I had this big agency hat. I knew everything that's going on at the agency. Then I went to work for Gerst, and I was like, wow, it's eye-opening for me as Gerst deputy of everything that was happening in human exploration, and then coming back to the agency in exploration systems development. Wow, we have a lot going on, really breakneck pace, and then coming into this role and seeing everything that this agency does, from 20 plus missions around the Earth, flying every day, just a lot of data flowing down to us, and we share it openly, to watching our human exploration side and space operations, to a credible thing like watching the count last night, being out there saying our hellos to Butch and Sonny as they're going out to the pad, realizing the incredible infrastructure that we have across the agency, and the reach that NASA has across the world that I see from a different perspective right now. And then for this community there, the people on the outside of NASA, without a NASA badge, but still part of the agency, because we all want these exploration goals to be achieved, what support we have, and how we can make sure we're being transparent and open and communicate what we're doing. That certainly has been a theme for the administrator and deputy administrator. I tried to do it from my knothole and exploration. But what we can do to continue to communicate everything that we're doing at the agency, and you just saw Patrick, who's a great example, a great ambassador for us, talking about what we're doing. It's not a secret. We're putting ourselves out there, and in order to get the support that I talked about, we need the support from the external community to get the resources that we need to do these great missions. And we'll explain our choices. Everyone might not agree with them, but we're going to explain them and talk about how we're going to get there for the future.
Jim, thank you very much for sharing your perspectives with us here at Humans to Mars Summit. I know you've got a super busy schedule, and I'm going to honor your time here, but let's thank Jim